Okay, so I'm going to work on part two of our video today, and it's going to be a little bit more in-depth version of buffers and when to use them inside of your guitar pedal designs. So right here we have our guitar pedal and guitar as always, or whatever you want to have, drum machines, whatever crap you throw in there. And your input and your output. This goes out into the world, wherever it may be, and whatever it may be doing. For me, I always use a buffer on the input and a buffer on the output. And I have my effects in between those. The reason I do this is because the buffer will take whatever is coming from over here, your guitars, your drums, anything, and it will take that signal and give it its unity gain, so it multiplies it times one. As mentioned in the last video, it's good if you have a lot of cable that you're working with, and you have a lot of parasitics. But for design, it's more important for me to know that I'm always going to have the same signal at this point. And the buffer does that. It acts as kind of an isolator between this world and this world. It also helps match impedance. So it takes this high impedance over here and turns it into a low impedance, which allows it to go through our circuit. It guarantees whatever my potential is going to be here, and it can work with our potential over here for whatever our effects are set to. And again, it kind of, the best way to describe this is you have this little block here, and this block makes sure that your delays, your phase shifters, anything that is dependent on your circuit, it is getting exactly what it wants. On this side over here, I use it for the same reason. So this is so whatever is going on in the world over here, I want to make sure that that's not feeding back into my circuit and messing with it. And again, it does impedance matching as well, and it acts as a barrier between the outside world and my guitar pedal. And it makes my guitar pedal reliable and puts the destiny of the sonic brilliance that my pedals make, all of our pedals make, in our hands. Additionally, inside of here, you can use a buffer for, you can split signals with them. You can have this send out to one path and this thing go to another path. You can also do level shifting, which is huge if you're running anything 5 volts or 3v3 at logic level. So right here we have our IC. Sometimes this will be like a delay IC, whatever you're using. Most of the time it's in the digital world. And this buffer is a really good form of a level shifter. And you can take this 9 volt potential and move it down to a 5 volt potential, whatever your signal is going. Level shifting also acts as a way to protect your IC. I think the last thing that I can kind of say that this does, a buffer can do, is you can have an inverting buffer and flip your signal upside down if you ever need to, which occasionally you do. So the little checklist here, we have a inverting signal, impedance matching, driving your circuit, isolation, protection, and level shifting. These are kind of the main reasons I use them. And I kind of drop buffers in all over the place because it gives me that peace of mind of knowing that my signal is going to be what I want it to be, where I want it to be at all times. Different types of buffers. There's op amp buffers. There is transistor buffers. Whatever you want to do, JFET, BJTs. And there's digital buffers. And these are probably the biggest ones that I could think of. There's some you can do it for signal conditioning, I think, as well. Um, but if you want to just look up different topologies of buffers, um, there's a lot of good resources out there. And I think that's it. Just this whole checklist.